I will put the problem in the correct order. And the question is asking us to identify domain and range, etc., 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 etc. Okay, so in part A, obviously I will determine the shape. Since the leading coefficient is -1, which is a number less than 0, I know now that the parabola has a maximum. Remember to redo the problems we do in class. That's your the best bet. First best bet. Okay. Then we have to determine the vertex, which, since they lucky us, the function presents the perfect square already. I mean, the square completed. So I know that the vertex is 2, 9. In part C, because it has a maximum, and the maximum is a positive number, X-intercepts exist. So X-intercepts, there will be 2 distinct solutions. I have to set f of x equal to 0. Negative x minus 2 squared plus 9 equals 0. I'm solving this equation. What do I need to do? Anyone can refresh our memory? I can never distribute because of the square. So I have to write this. I have to multiply both sides by -1. And now this is exactly what I was looking for. Why? It only requires us to take the square root and nothing else. And we get the solutions right away. This is a typical problem for taking square roots. We agree? So we apply the square root. And remember to get how many solutions? Very good. Plus or minus 3. Excellent. X equals 2 plus or minus 3. So we have x equals 5 and x equals -1. This is not enough. We have to write them as an ordered pair so we don't make a mistake. Not 5, -1 or -1, 5. Careful. Is 5, 0. Yes. I'm not saying that you said that. I'm just saying that that's what we need to show. In part D, we're asked to find the y-intercepts. It's basically only one, otherwise it would not be a function, so just the y-intercept. So I have to find f of 0. So let's do this together. How much is 0 minus 2? Very good. -2 squared. 4 times -1. And -4 plus 9. Excellent. 5. So this is 0, 5. After that, we have 3 more questions here. E, F, and G. E is asking us to find the axis of symmetry. This is not something that you see in my math lab. So, but I will ask you to. So that's why I'm going through all the steps. So the axis of symmetry, remember the vertex is 2, 9. So the axis of symmetry will be x equals. Very good. Awesome. Thank you very much. Indeed, is the vertical line passing through the vertex, and it must be x equals 2. X equals 2. Since this function has a maximum, max value is 9. Very good. E and F are always read from the vertex. And the range. And you can say the range, we haven't even graphed it. Yes, but we have everything covered. And what does that mean? The range would be? Right. -infinity to 9, because 9 is the maximum and the parabola has a maximum. This time I'm going to directly graph it on in my math lab. So okay, so first I would like to graph a line, which is the vertical line at x equals 2. This one. I'm testing my skills now. Okay, I'm assuming that that's okay. But I also want it not to be a solid line. It cannot be a solid line. This is the axis of symmetry. Okay, now I want to graph something like this. And I will definitely plot 2, 9. Okay, very good. Wait. So then I plot 5, 0. I want this point, and I want to plot negative 1, 0. I want this point, and it doesn't allow me because it's good enough. So how do I get out of here? Okay, very good. So this is done. Use the graphing tool to graph the equation. Use the vertex and one of the intercepts when drawing the graph. If it does not take the axis of symmetry, it's wrong. It has to be there. So let's check the answer now.
It doesn't.
Yeah.
But it's incorrect. I'm telling you.
Oh,
It is incorrect.
on the test. we
On the test, yes. I don't care what they say. On the test, you have to show the axis of symmetry. Okay, so to graph a blah, 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 blah. Okay, so I guess it will probably, this will clear all object drawn. Are you sure you want to continue? I don't want to,
Just hit delete.
oh, okay. Okay. So it's incorrect. So keep that in mind for the test. I will mention it in the requirement so you don't forget.
Okay.
It will be mentioned. It's incorrect. The axis of symmetry has to be there.
And also write the equation on the graph.
Yes, please. Yes. Very good. Good point. Is this okay? Any questions? Nick? Okay. So please redo the problems we do in class first. You will not have any difficulties after that. Good. Very good question. Thank you for bringing that. Any other question? Anything else? Do we have anything else, please? Yes, please.
What's on chapter 2?
It doesn't matter. Any chapter, please. Any chapter, any problem.
It was 2.8.2.
I don't care where it is. I'll find it. So you said chapter 2, section
It was 2.8.25.
uh,
I can't remember what.
2.2, you said?
Right. No, 2.8.
2.8. So this one. We want to preview the questions. So 2.85.
0.25.
I 2.825. Are you sure?
Right.
There is no question 2.5. Click on it.
Keep going. Keep going. Right there.
Okay, perfect. So in this problem, we are asked to find the midpoint. We are given a very good question, very good problem. So we have -7 thirds, comma 2 thirds, and -11 thirds, comma -8 thirds. Excellent problem. We're not asked to find the distance. We are only asked to find the coordinates of the midpoint. Ready? Good. So the midpoint has the average of the x values and the average of the y values. When I add this to this, I get -18 over 3. -18 over 3 is -6. -6 divided by 2 is -3. When I add these two, 2 over 3 minus 8 over 3, I get -6 over 3, which is -2. And -2 divided by 2 is -1. Very good question. Is this clear?
This is the midpoint, right?
Yes. Is this clear? All you have to do is add these two. -7 minus 11 is -18, but you have to divide by 3, you get -6. And now you divide by 2 to get -3. You add these two, you get -6 over 3, which is -2, but you have to divide it by 2 and you get -1. Perfect. Anything else? I'm very happy and proud of you. Please do the work. You're going to be very happy. Promise. Okay, anything else? Anything else? Okay, we're going back to 3.2 because we haven't done anything. We talked about two different things, but we haven't done anything. Okay. So the next topic is graphing, polynomial functions. I'm sorry, Nick, did you have something else? Anyone else? Did you have other questions? Anyone? Okay. Before I continue, since it's our last class before spring break, I would like to make sure that we can electronically communicate the entire course. 2 courses from last fall and last spring are already mentioned. Everything. Handouts, video lecture notes, everything. So you can move ahead. However, I would like us to have communication online. So I will email you, and please open a Google account, a Gmail account if you don't have one already, so we can chat through Hangouts or whatever else you want, Skype, whatever, phone, whatever. But I can't have 20 people on the phone, right? It's not possible. So we'll have to find a way, because this may last more than 2 weeks. It may last, who knows? Okay, so we have to be prepared. That's what they were telling us since yesterday morning. Okay? School may be closed for the next 2 to 3 weeks. But it doesn't mean that we have to continue. We have the obligation to continue, because otherwise it's going to continue into the summer semester, and then summer semester will be messed up. So we have to keep up. Okay? So I will email you. Please open a Gmail account so we can communicate. Okay? During our regular hours, we are going to be on the phone or on Google Hangouts and communicate about the class. Okay? So we have to establish this moving forward. Okay, so graphing polynomial functions, it's a long list. And you can say longer than this. Yes, a little bit longer than this. So look at how many steps we had for graphing a quadratic function. We had the shape, the vertex, X-intercepts, Y-intercept, axis of symmetry, max, min, and the range. We have a long list as well for polynomial functions, meaning degree 3 or more. Okay, so here's the list. Not necessarily in this particular order. First of all, domain. Number 2, X-intercepts and their multiplicities. 3, and behavior. 4, degree. 5, maximum number of turns. Maximum possible. I want to put a word in here. Very important. Possible. Maximum possible number of turns. By turns, we mean minimum or maximum that the function, the polynomial function, can have. Number 6. The values of the max min. Number 7. Range. Number 8. Symmetry. We mean whether the function is odd or even. And that's about it. And now we start with, can I turn off the MyMathLab? Can I log out? Log myself out from here? Okay. Good, it's done. Because I have to check the video if it's recording or not every now and then. Okay, perfect. Would you like to start with an odd degree or an even degree? Excellent. Let's start with an even degree. If you'd like to choose, they're on page 378. Or I'll show you the page right here. As you see, the first set, the functions are not factored. The second half, the functions are factored. Let's start with the factored one, and then we'll go back to the ones that are not factored. So please choose an even degree. 60? Yes, indeed. It is an even degree. Excellent. We'll start with 60. And that's on page 378. And it's f of x, negative x squared, x plus 2, x minus 2. Good problem to start with. Excellent. Good pick. Very good. I'm going to kindly ask you to use a version of this table. You create your own version if you'd like, but all the information has to be summarized somehow. If you don't like this table, you will not hurt my feelings, create your own. But you have to summarize the information somehow. Okay, so every time I go through any of this, I'll check it from the list and then we'll go back. Okay, so we have to start with the domain. Can anyone give us the domain of this function? Absolutely. All polynomial functions are friendly functions. They are never undefined. They're always smooth, continuous, no problem. Thank you very much, Bernie. Excellent. Okay, now, so I checked this. Now I would like to jump to the degree. Can anyone give us the degree? Four. Thank you very much. Square times x is degree 4. Thank you very much. Well done. Who was that, Tiana? Thank you. So that is done. Down the maximum possible number of terms. That is always degree minus 1. 4 minus 1 equals 3. This is the maximum possible number of turns. Again, by a turn, we mean either a max or a min. Question, yes? Yes, yes, yes. So let's think, I was going to explain anyway, but it's a very good question. Do we remember x cubed? Right, this is x cubed. What is its degree? How many possible terms can it have? Does it have any? No, it does not. By a term, we mean increasing, gets to a peak, decreasing, gets to a minimum, increasing, that's another term, gets to a peak, decreasing, that's another term. But x cubed, look at my hand. This is x cubed. It's always increasing. Although its degree is 3, and it can have maximum 2 terms, it doesn't have any. Which means the function cannot have more than 2 terms, but it doesn't have to have any. Of course, if it's an even degree, it will have to have at least a term. There's no choice. Because an even degree either comes from positive infinity going back to positive infinity, or it comes from negative infinity going back to negative infinity. But an odd degree doesn't have to have terms at all. Here's an example. X cubed does not have any terms. So the degree is 4. This function cannot turn, cannot have max min, more than 3 total. Does it have to have 3? No. But at least 1 it has to. Good. So that's the maximum possible number of turns, always a degree minus 1. Let's talk about the end behavior. What is the end behavior of this function? Meaning, what do I write here and here? That's the meaning of the end behavior. What? Correct. Degree 4, and the leading coefficient is negative. Awesome. Do we understand that? Please say no if it's not clear. The first example is always slightly I wouldn't say difficult to understand, but it's the first example, like everything. We do it the first time, it's not always the best, right?
What step was that? That we did that one? Out of like 8 steps?
Right here, and behavior.
Yeah, we can do it.
Yep, and behavior. Good. So what we have, the max min I forgot to mention. Of course, we cannot do this in this class. It has to be done with TI 84, 83, 82, whatever, 81, whatever you have. So this cannot be done by hand. So let's talk about the X-intercepts and multiplicities. So how do I determine the X-intercepts for this function? What do I have to do for any function? No, that's the Y-intercept.
Set Y.
Excellent. Great job. So when f of x is 0, I have negative x squared, x plus 2, x minus 2 equals 0. How many solutions will you give? It has to be the degree. There is no question. If the degree is 2, I have to give 2 solutions. If the degree is 10, I have to give 10 solutions. If the degree is 100 million, I have to give 100 million. I know I'm being silly. Okay, so then please give me 4 solutions. Yes. Excellent. What is the multiplicity? What does that mean? What does multiplicity do? Always. Is it a turn or a cross of the x-axis? Awesome. Awesome. Because we know x squared. X squared has 2 solutions at 0 and it turns. Awesome. And then we have x equals and x equals. Yes? And negative 2. And what is the multiplicity of each? Once. Very good. And is 2 plus 1 plus 1 4? Good. So we determine the x-intercepts and their multiplicities. I put them in the table. So you said 0, 0 twice. I make myself a note, a turn. At negative 2 and at positive 2, it's a regular cross. Any questions? Okay, this will be done with a graphing calculator. This I have to graph the function first. And let's talk about symmetry. How do I determine symmetry for a function? What did we calculate to show whether a function is odd or even or none of the above? We have to determine f of negative x. If it equals f of x, what do we say? The function is even. If f of negative x, we discussed that in chapter 2. We had a problem on the test or 2. If this is the case, then the function would be very good. If none of the above, then the function is not symmetric. Good. I'm going to give it a shot. Right? So I have to find f of negative x. But this will not change, but this will change, and this will change. Right? So let's give it a shot. So let's see what happens. F of negative x will be negative x squared, negative x plus 2, negative x minus 2. What happens here? Negative x to the second power is the same with how much is negative x times negative x? X squared. Excellent. Now I'm going to factor out negative 1 from here. And what is left in parentheses? Minus 2. I'm also going to factor out negative 1 from here. And what is left in parentheses? Very good. Awesome. How much is negative 1 times negative 1? 1. So then this is the new function. If they are the same, if f of negative x indeed equals f of x, then I would say the function is even. So can you tell me whether they are the same? They are the same. Awesome. So then I will say the function is even. So I'll make sure that the graph will be symmetric with respect to even functions. Have the graph symmetric with respect to. Very good. Y-axis symmetry. Perfect. Okay, here's my next step. And yes, as I promised, the first example takes a while. The next example will be much easier and shorter. Okay, it will take much less time. Ready? So let's give it a shot. See what happens. I will definitely plot the points I have. What points? I have negative 2, 0, I have 0, 0, and I have 2, 0. Right? Negative 2, 0. And that will be a cross. 0, 0, there will be a turn. 2, 0 will be a cross. The function is starting at negative infinity and crossing at negative 2, 0. Starting at negative infinity and crossing at negative 2, 0. Okay. Starting at negative infinity, crossing at negative 2, 0. It comes down back to the origin where it turns. So then it has to have a maximum somewhere. If it comes back down and turns at the origin, then it has to have a maximum somewhere. I don't care for the rest of the table. Why? Because I know the function is even. Whatever I have on this side, I have to have a copy on the other side. I can never make it perfectly symmetric. Almost, but never really perfect. So this is our graph. Negative x squared, x plus 2, x minus 2. And then you can say, okay, what about the max? I don't have them. I have to use the calculator. Do I know for sure that the maximum is here? No. It could be this. It could be this. That's not important. We're going to determine the max. Do I know that the function has a local minimum? Yes, I do. At the origin, 0, 0. But I cannot determine the local max without the graphing calculator. Ready? So please plug it in y equals negative x squared in y equals negative x squared in parentheses x plus 2 times x minus 2. I'm going to adjust the viewing window. Why would I adjust the viewing window? Because I already have the graph. I have the graph. Do I really care to see negative 10? No, of course not. It would be a waste of graph. I would care between negative 2, so negative 3 to positive 3, and negative 2 maybe to 10. And then I can adjust further. But I know exactly where to look for the graph because I already graphed the function. So I go to window, and I'll say negative 4, that's good enough, to 4, with a scale of 1, and the minimum negative 2 to, I don't know, maybe 10. I'm going to leave it. I have a cheat sheet here, as you see. So 10 is way too high. That's fine. So I'm going to say 7, and then I'm going to say graph. So here it comes. It crosses at negative 2, 0. It reaches a maximum that appears to be at 4. We'll check in a minute. It comes down because it has to turn again. We knew that. We knew from the table that it has to turn at 0, 0. And I don't even want to look at this side. I know it's even. So whatever I have on this side, I have to copy on the right-hand side of the y-axis. In order to determine this maximum, I know it appears to be around 4, but I don't know x value. I don't know the location. So here's what we do with second and calc. We will choose the maximum, number 4. choose the maximum, number 4, and then you have to give a left bound. The calculator doesn't know what you want. So I want this maximum, so I'm going to give the calculator a left bound as -2 with a right bound at 0. So now the calculator just knows that I want to get a maximum of this function anywhere between -2 and 0. I have to give the bounds. These are the bounds. And then it says guess. I don't want to guess. I just press enter again. And it gives me the exact value of x coordinate and the y coordinate of the vertex. There's no vertex unless it's a quadrant of the maximum. So the maximum value is when x is -1.4 and the maximum value is 4. I will go back to my table and put it in. So in my table I will write -1.4, 4. And can anyone, we didn't calculate the other side, can anyone give us the maximum on the other side? Excellent, thank you. Great job. And that's it. Now I can identify the range. Can anyone give us the approximate range? We cannot really identify it 100%. Can anyone give us the range of this function? Definitely from till, yeah. So we can identify it. I was thinking about x value for some reason. 1 second. So we can identify the range exactly. That's all I can teach you about polynomial functions, and there is nothing else. Now please choose any other function.
Can you go down to the table again?
Yes, of course. And I would like us to look at a word problem and then go back and graph some more.
Thank you.
Sure, anytime. Anything else? Yes, please.
Is that how you want us to write an answer on the chart, or do you want us to go like 1, 2, 3, 4 down paper and write an answer to?
You mean here for the max?
Yeah.
If you have the table, the table filled up and with the symmetry, because you see the symmetry doesn't fit anywhere. I just have to attach it somewhere. And the graph, I'm fine. You don't have to identify anything specially. I don't want you to spend more than 3 minutes on a problem like this. Please don't. Please, there is no need, okay? So let's look at this word problem. Because I know you want to know where is this applied. So here's an example. Oops, I didn't mean that. I meant this. Here's an example, and let's read it. Doing a diagnostic evaluation. So health field, which is very popular, wonderful topic. A 33-year-old woman experienced a panic attack a few minutes after she had been asked to relax her whole body. The graph shows the rapid increase in heart rate during the panic attack. Okay, so let's take a look and analyze the graph. She came in. A minute later, it says heart rate right here and time in minutes. Her heart rate started increasing. 4 minutes later, this is what I see from the graph. And then at minute 4, her heart rate starts decreasing till minute 8. At minute 8, something must have happened because it turns around and it goes up. And it reaches a maximum at minute 10, and then it starts decreasing till minute 12, where it's roughly under 90. Measurement unit, beats per minute. So let's see the first question. For which time periods during the diagnostic evaluation was the woman's heart rate increasing? The woman's heart rate was increasing between 1 and 4, union
8.
10. Excellent. We just follow the graph, right? So we know exactly what the graph is telling us. So between 1 and 4, union between 8 and 10. Great job. For which time periods during the diagnostic evaluation was the woman's heart rate decreasing? And 8. 10 and 12, union 10 and 12. We've done this in chapter 2. We're applying it now in chapter 3. Okay. How many turning points? do we see? Follow my explanation here. Yes. Up, down, up, down. 1, 2, 3. Agreed? Yes? Okay, how many yes?
I was agreeing with you.
Okay, how many turning points? 3. Suppose that a polynomial function is used to model the data displayed by the graph. Use the number of turning points to determine the degree of the polynomial function that could fit the data. 4. If there are 3 turning points, the minimum degree, it could be degree 10, but the minimum degree for 3 turning points is 4. Do we agree? Number of turning points is the degree minus 1, so we are going backwards. We have the number of turning points, we are adding 1 to determine the degree.
Okay.
Good. For the model in part D, should the leading coefficient of the polynomial be positive or negative? Look at this. Should the leading coefficient be positive or negative?
Positive.
If it's positive, remember x squared. X squared has a positive leading coefficient.
Then it should be negative.
Negative indeed. I agree. Negative. Okay. Use the graph to estimate the woman's maximum heart rate during the first 12 minutes. Where is the maximum heart rate? At 10 is the maximum heart rate. Very good. After how many minutes? So the maximum heart rate is, I would say, 115, maybe right in the middle, maybe 118. 118. After how many minutes? Yes, at 10. Final question. Use the graph to estimate the woman's minimum heart rate. What was the minimum heart rate? Not at 8. The minimum heart rate is the function value, not when. 60 is something very difficult to read. I would say, like you, 62, 63. That's fine. After how many minutes did this occur?
8.
After 8 minutes, indeed. See how we apply this? And there are many other applications in the same way. Because they are not, they cannot be modeled by an absolute value function or a linear function or quadratic. It has to be a polynomial. Okay. To conclude this section, please choose any other polynomial, any degree you want, factored or not, it's up to you. Oh, I'm sorry. Yes, so let's do an odd. Which one? 42, it is odd. Excellent. Great job. So let's do 42. So problem 42 on page 378, and that is f of x to the third plus x squared minus 4x minus 4. Good.